Hi, I'm Carter, and today I'm going to be presenting our project on a classic image classification and reconstruction problem using the CIFAR-10 dataset. Our team consists of Zheng, Chen, Aydin, me, and Jacob Landicho. I'll be walking through each part of the project, including the overview, instructions and run-through, and conclusion. So our goal for this project is to solve a machine learning problem using the CIFAR-10 dataset, where we specifically aim to first classify images into 10 different categories using a convolutional neural network, and then reconstruct images and understand the representations using a variational autoencoder, as well as conduct a comparative study to evaluate and compare the performance of these models based on accuracy, training time, and capability. And lastly, I will demonstrate a practical application by deploying the trained models in a system where users can upload images and receive predictions. So essentially, the primary learning problem in this project is first supervised classification. So given an input image from the CIFAR-10 dataset, can we accurately predict which of the 10 classes it belongs to? And in this case, we're training a model, a convolutional neural network, using labeled data. And second, an unsupervised reconstruction. So instead of predicting a label, can we train a model to learn a compressed representation of an image and then reconstruct it as accurately as possible, which can be addressed using a variational autoencoder. So the dataset for this project is a collection of 60,000 color images with a resolution of 32 by 32 pixels, divided into 10 classes. And we sourced the dataset from Kaggle for convenience, but it originally comes from the University of Toronto. So here's the dataset and the classes it has. So airplane, automobile, bird, cat, deer, dog, frog, horse, ship, truck. So first things first, you need to install the necessary Python libraries for data analysis, which can be completed using the following command, as shown here. And in terms of loading and pre-processing the dataset, it needs to be downloaded from Kaggle and then placed in your Google Drive within a folder named CIFAR-10. And we processed the data by normalizing pixel values to a range between 0 and 1 for efficient training, and performed a train test split of 80% training and 20% validation. And here's just a demonstration. So download, then place into a folder named CIFAR-10 in your drive. And so we implemented two models. First being the convolutional neural network, which is a supervised model with two convolutional layers, followed by fully connected layers. And this model classifies images into one of the 10 CIFAR-10 categories. And the second model being the variational autoencoder, which is an unsupervised model with an encoder that compresses images into a latent space and a decoder that reconstructs the images. And the variational autoencoder learns meaningful representations of the images. Showcasing, defining the models. Run this, just defining the classes for each model, and then initializing them. For training the models, we used the cross-entry loss function for the convolutional neural network to measure classification error, and the mean squared error loss function for the variational autoencoder to measure reconstruction error. And we used the Atom optimizer with a learning rate of 0.001 for both models. And here are the results from training our models. So for the convolutional neural network, over 10 epochs, the training loss decreased from 1.50 to 0.45. And the validation loss stabilized around 0.89 to 0.93, showing that the convolutional neural network effectively learned to classify images. And for the variational autoencoder, the reconstruction loss decreased steadily, indicating that the variational autoencoder successfully reconstructed images. Okay, and now showcasing, defining the training components as well as the training loop, running this code block to run the epoch and obtain the value or loss values for each model. And so once that finishes running, it'll return your training loss and validation loss values, as well as your variational autoencoder loss values. So in comparing the two models, the convolutional neural network achieved high classification accuracy on the validation set, showing that it's suitable for supervised tasks where labeled data is available. And the variational autoencoder learned and reconstructed images well, showing that it's useful for unsupervised tasks and understanding latent features. Okay, and just going over the comparison of the models in the code. So running this to print out the training and validation loss statements for the convolutional neural network, as well as the results of the variational autoencoder, printing out the pixels for each image. As you can see, it reconstructs the image quality quite accurately. And now for the application demo, where we can see our convolutional neural network in action by classifying an image. So this part applies our trained model to a selected image with this path to the user's Google Drive. And the images are uploaded and read by the model from the CIFAR-10 folder. So these are some of the images I'm going to be testing out. This one, airplane, horse, frog. Alright, so you can replace this image path with any image in your CIFAR-10 folder to test the model further, but I'm just going to be testing these ones. So ship, predicted ship class, car, predicted automobile class, airplane, predicted airplane class, horse, predicted horse, and then frog. So, in conclusion, this project demonstrates the effectiveness of convolutional neural networks for supervised image classification, as well as the potential for variational autoencoders for unsupervised image reconstruction, and is a practical approach to solving machine learning problems using different neural network architectures. Thanks for your time.